Okay, good evening, good evening. Uh, Today's session we focus on module 10, LAN Security Concepts, where basically we introduce you to security at a layer 2. Uh, I think we all understand at this point how critical network security is and should probably the primary focus for you as an engineer, as a security architect, as a network admin, um, mainly because we have a couple of things, uh, right? We have a couple of things which network security provides for us, which is very important from data protection. I think there is need to safeguard sensitive information. Um We also have issues with denial of service, DOS. I think we'll get to discuss that later on. So network security is important in that aspect that we can have attacks that can deny uh, users, legitimate users, access to services that the network has to offer. So having a secure network is very important in that aspect. We also have cyber attacks. I think cybersecurity is a bit different. Here we focus on layer two security, but I think vulnerabilities at layer two will basically overall lead to what we call cyber attacks. But cyber attacks is more to do with attacks due to malware. I think we did security in CCNA 1 where we discussed what malware is. So if you have layer two vulnerabilities, that can lead to those type of attacks as well. So we have malware, we have distributed denial of service, uh, everything. Just an introduction of why network security is important. Now, in this one, we'll focus on endpoint security, how endpoint security, how we use endpoint security to mitigate attacks. We have access control, who gets access to the network. Basically, layer two security threats. We'll discuss the type of threats that we have and mitigation. How do we prevent or protect the network from those attacks? Getting into it now, endpoint security. Uh, News media commonly covers attacks on enterprise networks. Most likely, these attacks will involve one of or more of the following: distributed denial of service, data breach, and malware. So I think networks of today involve one or more of these type of attacks that we have. DDoS, where we have a coordinated attack from many devices that we call zombies. Uh, this is basically to bring down the network. DDoS is an attack that holds the network basically. Uh, so that my services that were supposed to be offered by the network, they are no longer being able to be saved. That's an attack in its own. So an attack is not necessarily only getting information or getting sensitive information. It's also about stopping the network from performing what it's supposed to perform. So that's what we have with DDoS. We have data breaches where an organization's data servers or hosts are compromised to steal confidential information, with malware, uh, where the hosts are infected with malicious software. There's an example of ransomware where data is encrypted and locked. You're basically logged out of your own system. Then someone asks if you pay, then we can decrypt whatever they had logged out. Those are some of the type of attacks that we have in networks of today. Now, looking at security devices that we can have that can basically protect us, that can protect the network from outside access. We have the VPN, next generation firewall. Then we have the NAC, network access control. The VPN enabled router. So that one, it works basically by encrypting traffic between either a remote user or a site. Um, so the link between that user and the enterprise network, usually, which goes over the public internet, information is encrypted. We create a private link within the public network. That is basically what VPN does, therefore securing our network. So over the internet, public, we create a private tunnel and we use that tunnel to send and receive messages. That tunnel is basically being created by encryption. That's one way of that's a security device that we have. So this is a VPN enabled router. The router is enabled to perform that service. Then we have next generation firewalls, which provide stateful packet inspection. So this one is more of an advancement of the basic firewall. Unfortunately, not unfortunately, CCNA doesn't delve much into my firewalls. Uh, but my firewalls, they are very effective in preventing my attacks. So with the next generation firewall, it's a little bit of an upgrade from the basic firewall that we have. With this one performing intelligent traffic filtering as well as threat prevention. Then we have the network access control, which basically performs what we call the triple A, authentication, authorization, and accounting. This is as well important. Who gets access? I think authentication is who gets access, authorization, who gets access to what. Then after they get access, what are they doing? That is all part of security. So we have the network access control being responsible basically for that, ensuring that only authorized personnel get access to the systems, to the network basically. Endpoint protection, endpoint endpoints are hosts, commonly consists of laptops, desktops, IP phones. Endpoints have typically used traditional host-based security features such as antiviruses. Endpoints today are best protected by a combination of NAC, AMP software, ESA, and WSA. So basically, endpoint security, I think it's as well as crucial as any, because I think most attacks that attacks that affect our networks, they come from the endpoints. I think it should be, I don't want to put a number on it, probably above 90%. They come from the endpoints. Either, especially the emails, enterprise attacks, emails, phishing, spam, over most of the attacks go. So I think endpoint protection is very critical. Endpoint protection is very critical because most of the attacks that attack the network, they come from that end. Um in that aspect, it requires what we call a multi-layered approach. A multi-layered approach where you don't only have one way of preventing the attacks, but you have many ways, not only one. I think that diagram Ratina Rapo shows perfectly a multi-layered approach in preventing my attacks. So you can see we have our network this end. Probably they need to get access to the internet. Those are the our end devices. To get access to the internet, however, you can see there is a layer of security that we have there, a VPN-enabled router, which encrypts traffic between the public network, uh, the end user who is in the public network, and a user who is within the enterprise. So the VPN-enabled router creates a tunnel which basically encrypts all the traffic that is between our enterprise and a remote user. Then from there, you have the next generation firewall, which basically performs packet filtering. That's another layer of security that we have there. Then within the network now, you can see it in a NAC where we have AAA being performed authentication. That's another form of security that we have as well. Then we have email security appliance, web security appliance. If you are trying to probably connect to the web or you're contracting via you're connecting via to the email servers, then there is security with that respect as well. So those two are responsible for monitoring the other one, I think SMTP, monitoring traffic, SMTP traffic, therefore preventing attacks that are in the spam, and we also have phishing attacks via the email. From there, we also have endpoint secured here with AMP. Endpoint secured with AMP, that's another form of security that we have there. Advanced malware protection. So, in conclusion, endpoint protection is very important and it comes as a multi-layered approach. You don't only have one way of preventing my attacks. For example, you cannot only use AMP here because kubva internet kwesoko network inogona kuto attack from this end. So at probably every node, there is need to have a form of security that prevents against my attacks. Cisco email security appliance. So with that one, it's basically a device designed to monitor SMTP, which constantly updates with real-time feeds from Cisco Talos. It detects, correlates threats and solutions by using the database monitoring system. Some of its functions: block known threats, discard emails, block access to newly infected sites, encrypt content. Right. This is another device which is very important. Like I said, I think almost 90% of attacks on enterprise networks, they are via emails. 90% of attacks on enterprise networks, they are via emails. So there is need to have effective methods that mitigate against those attacks. And what we have the email security appliance, which helps us in doing that. Then here we have the Cisco Talos. This is basically a database which is constantly being updated with the latest threads. How do I put the signatures? We have threads, they have signatures that they have. And this Cisco Talos is constantly being updated kuti pane threat yakadai yakadai. Then from those updates, these devices like the email security appliance, it gets those updates. Therefore, it knows the latest threats which are out there. That's basically the idea behind Cisco Talos. It allows for devices, if updated with the database, to be able to know the latest threats that are out there. Cisco Web Security Appliance, that's another device which, in this case, it monitors web traffic. It can be used to monitor, let me see, it combines the AMP application visibility, control, acceptable use policy, and reporting. Let me see, the WSA can perform blacklisting, URI filtering, malware scanning, web application filtering, then encryption, decryption of traffic. So this one, it basically manages our enterprise's web traffic, like highlighted, providing AMP, which basically detects, blocks as well, malware that is in Ingerimu. When we browse, there's a lot of malware in Ingerimu. So this appliance, web security appliance, is responsible for blocking some of that malware in our web content. It is also used for URL filtering, which basically blocks access to some websites. Recently on campus, I think they're using one of these. It's probably not this, because ACLs can also perform the same thing. But if they're using this, it is being used to block. For example, you cannot get on TikTok if you are at the UZ campus. You cannot get on. You cannot download torrents, stuff like that. So either they're using control list or access control list, or they're using that specific device, which basically blocks or doesn't allow access to some websites. Then we also have web application filtering there, uh, which blocks applications instead of websites. So you can block websites using the URL, but this one actually blocks some applications. And lastly, we have encryption and decryption of web traffic. All these are just forms of securing our web traffic. Then we have access control, right? Authentication with the local password. Right, we have many types of authentication performed on network devices, varying levels of security. With the varying levels of security, the simplest method being remote access authentication using console logins. Then we have the other one, SSH, which is more secure form of remote access, requiring a username and a password. The local database method has some limitations. User accounts must be configured locally. The method provides no fallback. Right here, we start with authentication. By definition, uh, it's sort of how a user identifies themselves to the network. Who are you to the network? That is basically what authentication is. When we did CCNA1, part of that, we used those passwords, uh, which basically allows you to get access to a networking device. However, this simple method of getting access, it only use a password. There is no username, so there is no way of identifying who actually gets access to the device. On the other hand, SSH is another way of getting access to to a networking device remotely. It can be a switch, router, a firewall, a LAN controller, whatever that device is. SSH allows us to get remote access. Difference with this one, you can see SSH, there is a username and a password. So in this case, a user has to identify themselves. There is a local database which is created within the device, which allows every time someone tries to get access to that device, they have to use their username and their password. And that's how we identify with Diana want access. If we add the other A for accounting, for example. All right. The local database method, there's some limitations. Right. So like I said with this one, I hope you remember when you did SSH, here this point here, Irape, they talked about creating a database, a local database. When you say local database, it's basically meaning my usernames, my passwords, they are on the networking device which we are trying to access. So if I'm trying to access a router via SSH, then my usernames and my passwords are the same router error. It has my limitations. User accounts must be configured locally. The method does not provide fallback authentication method. The method provides no fallback authentication method. So creating my usernames on the local device, you see, here they didn't talk about scalability as well, because how many usernames and passwords can you actually create on that specific local device? You probably need for scalability, you probably need another server to store those names and usernames and passwords. So local authentication, okay for very small networks, but for much larger networks, uh, it will probably not be as much effective. AAA components, not much here. Authentication, authorization. It's a way to control who is permitted access, what they can do, and audit actions they perform whilst accessing the network. AAA. All right, the authentication part, I think we've partly touched on this one. We have local authentication, where usernames and passwords are stored locally. Then the other one, we have server-based AAA authentication, where the usernames and passwords they are stored on a server. They are not on the local device. Then communication between that server and our device is either via radius, a protocol, or TACAX plus another protocol which can be used. Which one is for Cisco here? I'm very familiar with this one. I've never used this TACAX. It will probably be that radius is Cisco proprietary, maybe. So server-based AAA authentication, instead of having our database locally on the networking device, in this case, we have a server. So basically what that means is authentication is happening at the server. The server is the one which is providing the AAA services. Authorization. Right, before I have this simple thing. All right, so in local, yeah, how do I put this? So let's say I have a PC, which is our client, then we have a router. So this is the local authentication. The process. So local authentication, this user tries to connect to the network via the router. Let's say for our network here. User is trying to get access to this network. This router prompts for either username or just the password, depending on if you're using SSH or you're just using the VTY connection. So if you're using SSH, then this router prompts for the username and password. Then the client responds with the username and password. And if correct, that's how they get access to the network. This is local authentication. Everything is happening via this route. However, for server-based difference, for server-based, here we have, let's have a server somewhere. Our server, and this is our client, right? So if this one tries to connect, then the router is the one that prompts for username or password. Then this one, how do I put this? A client requests to connect to the network. A router prompts for username or password. A router queries. Let me try to figure this out. Queries the servers. Hey, the process just got complex. This one prompts, tries to connect. This one prompts. This one sends the username. This one sends it to here. Then this one allows. Okay, I got it. Right. So server based, not as complex as I want it to be. Right. So if this one tries to connect to the network, this one prompts for username and password, but it doesn't authenticate. So username and password goes to the server, and this one is the one that authenticates. Then it tells the PC if it has access or if access is denied. Authentication is happening here, now not on the router. So this is just acting sort of as an intermediary device, server-based. Uh, right. Server-based authentication. Communication via those two protocols, Radius and Tagax Plus. Authorization. Authorization is automatic and does not require users to perform any steps. It governs what users can and cannot do. What are you authorized to do? It uses a set of attributes that describes the user's access to the network. These attributes are used by the server to determine privileges for that user. So authorization doesn't have much. It's basically what are you allowed to do on the network. It's usually if you try to connect to the AAA server and you are not allowed to do whatever you wanted to do, you get a message not allowed. So it's either a pass or fail kind of a thing. And that is authorization. Accounting, AAA collects and reports usage data for purposes such as auditing or billing. So it's basically auditing who did what, and when. Very important. That's auditing. Billing, I think something to do with money charging. So with accounting, we allow the network to be able to audit as well as bill. The collected data includes start, stop, connection times, executed commands, number of packets, number of bytes. So with accounting, we're able to see when someone connects to the network, when they left the network, what packets they sent over the network, how much information they've sent over the network. I think this is very important as well in troubleshooting. If you know uh, when someone got access and when they left the system, you can probably figure out when the network started malfunctioning, started not working correctly using accounting. Then you go back to the baseline and start troubleshooting using information from accounting. Primary use of accounting, detailed log of exactly what authenticated user does on the device. Log contains fields including the username, date, time, actual command entered. Very important. If it includes actual commands entered as well, panogonaoneka kuti ndo padhakura network ipapo. If we don't have that, that's a problem. Accounting 802.1x. 802.1x is a standard for port-based access control. Port-based access control. So with this one, what we have, it restricts unauthorized workstations from connecting to a LAN through accessible switch ports. The server authenticates each workstation connected to a switch port before making available any services offered by the LAN. We have devices that have specific roles, the supplicant, the authenticator, and the authentication. The client, excuse, the client, this is basically the endpoint that is requesting access to network services. Then the authenticator is the device which controls the port, basically acting as an intermediary between the supplicant and the authentication. Then the authentication, that's basically the server, which verifies the client's identity, therefore authorizing access. It's sort of the same when I described server-based authentication. I think this is sort of the same setup where you have the client, then we have the authenticator playing the intermediary, then we have the server on the other side. So this one is mostly used by devices which have more ports where end devices get direct access to those ports. I think we'll get to discuss switch port security, I think in the next slides. Layer 2 security threats, layer 2 vulnerabilities. The OSI reference models is divided into 7 layers. Okay, we know. Administrators routinely implement security solutions to protect elements layer 3 up through layer 7 using VPNs, firewalls. However, if layer 2 is compromised, all the above layers are also affected. Right, so whilst we typically focus more on security of the upper layers. For example, we are all familiar with antivirus. We are all familiar with firewall, which basically acts kubva panapa kuenda kumusoro. Firewall, ma antiviruses edu probably acting kumusoro kunogezwo in the application layer. What else was mentioned here? My VPNs anotangira layer 3 achikwira kumusoro as well. Your IPsec anenge arikubva layer 3 achisvika kumusoro. That's okay. That's security for all those layers. But however, if a layer iri rikasiwa riri vulnerable, that does not matter. Because once we get access to the network via this, it means all security yaiswa kumusoro haina zvairi kubatsira, because we can still get access to the network via the layer 2. So layer 2 security is very important in that aspect. Right. Attack categories. Security is only as strong as its weakest link. LANs are traditionally under admin control of a single organization. We inherently trusted all persons and devices connected to our LAN. Today, with BYOD and more sophisticated attacks, our LANs have become more vulnerable to penetration. So basically, here we get introduced to switch attacks. We don't have to trust every device that is connected to our networking device. A couple of attacks introduced there with the marketable attacks. We have Mavilan attacks. I think we'll get to discuss them in subsequent slides. DCP attacks, ARP, address spoofing. Then we have STP attacks. Let's go through them one by one. Mitigation. Okay, mitigation with port security. That's all 802.1x. Yeah, don't want to discuss DHCP snooping, DAI, IP, source guards. Those are some of the ways we can mitigate those attacks. I'm avoiding getting into these issues because I think in the following slides, we'll discuss that in detail. Switch operation review. Here we get to look at recall that to make forwarding decisions. A LAN to switch builds a table. This is called the MAC address table. Right, so here it's basically a review of how a switch works. Let me so I have 2 minutes. How a switch works, because if you understand how a switch works, start here. Layer 2, it means we're talking of attacks via this device, the switch. If you understand how the switch works, then it becomes easy understanding how we have the type of attacks that we have, the layer 2 attacks. And how the switch works basically is if you are trying to send traffic from a point, let's say from a point A to B, a traffic is kapa switch yako, we have the MAC address table, which learns my addresses. If we don't have my addresses learned already, then it is always broadcasting traffic here receiver so that it learns my addresses as well as learn where to forward and which port to forward. So basically, that is how a switch works. By these processes, automated learning, then we have broadcasting, then we have which is this one, filtering, learning, broadcasting, filtering, then forwarding. That is what basically describes how a switch functions. So from there, if we understand those things, we can then look at my attacks from this point. Because in and over my attacks actual by learning, broadcast, filtering, and forwarding. I can see my time is almost up. I think let's have one more session and we'll probably be done.